Ozone depletion and global warming are two major environmental issues that affect the Earth and its inhabitants. Ozone depletion refers to the thinning of the ozone layer, which is a protective shield that absorbs most of harmful ultraviolet radiation from the sun. Global warming refers to the increase in the average temperature of the Earth's surface and atmosphere, which is caused by the accumulation of greenhouse gases such as carbon dioxide, methane, nitrous oxide. Both ozone depletion and global warming have negative impact on the environment, human health, and biodiversity. In this lesson, we will learn about the causes and effect solution of those two problems. We will also explore how they are related and what we can do to protect our planet. First, we talk about ozone layer, structure, thickness, importance, and erosion. Then we discuss global warming causes and effect. So the ozone layer is the layer in the stratosphere from 20 to 40 kilometers above sea level. So why exactly in the stratosphere layer? Because the stratosphere layer has enough amount of oxygen and faces the ultraviolet radiation coming from the sun. So the ozone layer forms in the stratosphere because it's the first layer in the atmosphere which contains suitable amount of oxygen and faces ultraviolet radiation. So why it's important for the oxygen to face the ultraviolet radiation to form ozone layer? Let's take us to the structure and formation of ozone layer, where the ozone layer is composed of 3 oxygen atoms, and in the first step, the oxygen absorb the ultraviolet radiation, and that causes the oxygen atom to split into 2 single oxygen atoms. So the oxygen gas molecule absorb ultraviolet radiation, which causes the breakdown of its double covalent bond to give 2 free oxygen atoms. Then each oxygen atom combined with oxygen molecule forming the ozone molecule. So each free oxygen atom combines with another oxygen molecule forming the ozone molecule, which is composed of 3 oxygen atoms. And because the atmospheric pressure in the stratosphere layer is 1/1000 bar, and the temperature is less than at sea level, the ozone layer spread over 20 kilometer thickness. But came the scientist Dobson, and he postulated that the thickness of ozone layer, if it compressed under the STP, meaning standard temperature and pressure, would form a layer only 3 millimeter. And the STP means standard temperature and pressure. Standard temperature 0 degrees Celsius and standard pressure 1 atmospheric or 13.25 millibar. So Dobson assumed that the normal degree of ozone is 300 Dobson, where each 1 millimeter is equal 100 Dobson. So what are the importance of the ozone layer? We have 3 types of UV rays. Ultraviolet rays differ in the wavelength. The measuring unit of the wavelength is nanometer. We have the far ultraviolet rays, which range from 100 to 220 nanometer. Medium ultraviolet rays range from 280 to 315 nanometers. And the near ultraviolet range from 315 to 400 nanometers. So the near ultraviolet completely penetrate the ozone layer and reach Earth, and it's useful for living organisms. The medium ultraviolet don't penetrate Earth by 95%, and it's harmful for the living organism. The far ultraviolet, and it's the dangerous of them all, don't penetrate the ozone layer by 100%. So the far ultraviolet is completely blocked by the ozone layer. So the ozone layer acts as a protective shield that protects the living organism from the harmful radiation, which is ultraviolet radiation. And the scientists noticed that there is an erosion of the ozone layer above South Pole, which is known as the ozone hole, and it's increased in September each year. And that's because all the pollutants assemble as a black cloud that pushes by the wind toward the South Pole, increasing the depletion of the ozone layer. And the ozone hole is not an actual hole in the ozone layer, but it's a decrease in the thickness of the ozone layer. So ozone hole, it means thinning or losing part of the ozone above South Pole. And this is a representation of the ozone hole through years. The green area is 300 Dobson, and the violet area is less than 300 Dobson. And as you see, with years, the ozone hole increases. So how can we calculate the degree of ozone depletion? The degree of erosion equal the normal degree of ozone layer, which 300 Dobson, minus the degree of ozone in this area, and the percentage or the ratio of erosion equal the degree of erosion in the ozone layer over the normal degree of ozone multiplied by 100. So what is the percentage of erosion of ozone layer in an area if you know that the degree of its ozone is 150 Dobson? First, we get the degree of erosion equal the normal degree of ozone layer 300 minus the degree of ozone in this area 150 equal 150 Dobson. Then the ratio of the erosion equal the degree of ozone in this area, which is 150 over the normal degree 300 multiplied by 100 equal 50%. So what causes the ozone hole or the ozone depletion? The pollutant of ozone layer. First is chlorofluorocarbons compound, which used as a cooling substance or inflating substance in packing, or an propellant substance in aerosols. The solvent substance of cleaning electric circuit. Second, the methyl bromide gas, which used as insecticide. The halons, which used as extinguishing fires. The nitrogen oxide, they are produced from burning coal or fuel in the ultrasound Concorde aeroplane.
15 to 35 kilometers above Earth's surface, a gas called ozone surrounds the planet. The ozone layer acts as a barrier between Earth and ultraviolet radiation from the sun. However, pollution has caused the ozone layer to thin, exposing life on Earth to dangerous radiation. Earth's atmosphere is made up of 6 layers. The second layer, called the stratosphere, contains the ozone layer. The ozone layer is made up of a highly reactive molecule called ozone, which contains 3 oxygen atoms. Ozone is a trace gas in the atmosphere. There are only about 3 molecules for every 10 million molecules of air. But it does a very important job. The ozone layer acts as Earth's sunscreen, absorbing about 98% of damaging ultraviolet or UV light. But the ozone layer has gotten thinner. Chemicals called chlorofluorocarbons, or CFCs, are the primary culprits in ozone layer breakdown. A CFC is a molecule that contains the elements carbon, chlorine, and fluorine. CFCs are mostly found in refrigerants, aerosols, and plastic products. When CFCs are exposed to ultraviolet rays in the atmosphere, they break down into substances that include chlorine. The chlorine reacts with the oxygen atoms in ozone and rips apart the ozone molecule. Areas of damage in the ozone layer are often called ozone holes, but that name is misleading. Ozone layer damage is more like a thin patch, with the thinnest areas near the poles. The ozone layer above the Antarctic, in particular, has been impacted by pollution since the mid-1980s. There, the region's low temperatures speed up the conversion of CFCs to ozone-damaging chlorine. About 90% of CFCs currently in the atmosphere were emitted by industrialized countries in the Northern Hemisphere. In 1989, the Montreal Protocol banned the production of ozone-depleting substances. Since then, the amount of chlorine and other ozone-depleting elements in the atmosphere have been falling. Scientists estimate that chlorine levels will return to their natural state in about 50 years. By then, the Antarctic ozone hole will shrink to smaller than 8 million square miles.
Second, the global warming. Researchers of the IPCC, the Intergovernmental Panel of Climate Change, that follow the UN, or the United Nations, showed that there is an increase in the average temperature of the Earth's surface, known as global warming. So the global warming is the continuous increase in the average temperature of the Earth's near surface air. And here is the researchers' work. So as from the year 1890 to 220, there is an increase in the Earth's average temperature by 100 degrees. And all the different lines represent different research stations. So why do we care that the Earth temperature increased by 1 degree, just 1 degree? We know that the difference in temperature between summer and winter may be 5 or 6 degrees Celsius. That's because the day-to-day temperature depends on how much sun rays, the rotation of the Earth, the cloud, the wind. So many factors affect day-to-day temperature. But the temperature of Earth, or average Earth temperature, depend on the difference between how much Earth receives energy and how much it reflects back. So the amount of temperature needed to rise the whole Earth by 1 degree, it's an immense amount of energy. And that's how the Earth's temperature look like through the years. Notice how Earth increase in temperature and get hotter and hotter by the years. So this picture is until 222. So what are the causes of the climate change or the global warming? Is greenhouse gas effect, or the greenhouse gases, which are carbon dioxide, methane gas, nitrous oxide, chlorofluorocarbons or CFCs, the water vapor. And the carbon dioxide is the major effect or the major greenhouse gas that trapping the infrared radiation and increasing the earth temperature. So the carbon dioxide is the primary greenhouse gas emitted by human activity. So in normal greenhouse gas concentration, see the sun rays are reflected back to the atmosphere. See the difference between how much Earth absorb and how much it reflects. And as we increase the greenhouse gas effect, most of the coming rays, the reflected infrared, come back to Earth, and just a tiny amount that escape to space, and that infrared radiation what caused the increase in the Earth's temperature. So in normal greenhouse effect or normal greenhouse gases concentration, the sunlight passes through the atmosphere and the Earth radiates the heat back to space. Most of the sunlight or the reflected rays from Earth escape to space. But as we increase the greenhouse gas, the Earth absorbs these rays and re-emit the radiation in the form of infrared radiation. The infrared radiation cannot penetrate, cannot escape through the atmosphere because it has long wavelength, and then they reflect back to the Earth or keep trapped in the troposphere, causing the rise in the planet Earth temperature. And that's what means by the greenhouse effect. So as we increase the amount of carbon dioxide or the greenhouse gases, the Earth absorbs through the day, it absorbs the sunlight and the heat coming from the sun, and then it re-emits those heat in a way of infrared radiation. The infrared radiation cannot penetrate the atmosphere and escape to space because they have long wavelength, and so they reflect back to Earth, and the Earth absorb those infrared radiation, and that causes the increase in the air and increase the temperature of Earth. So the greenhouse effect is the trapping of the infrared radiation in the troposphere due to the increase of the percentage of the greenhouse gases, and that increases the Earth's temperature. So what are the causes of what increases the greenhouse ratio in the atmosphere? The fossil fuel burning. As we burn fossil fuels, coal, oil, petroleum, they release carbon dioxide and increase the greenhouse gases concentration. The forest fire, also as the forest burn, they release carbon dioxide. And the cutting trees, because trees absorb the carbon dioxide, and as we cut the trees, we increase the concentration of the carbon dioxide in the atmosphere. And among the dangers of the global warming is the Arctic melting and severe climatic change. And Arctic melting causes the extinction of the polar animals because they depend on the ice to live, and as the ice melt, make those animals face extinction. The second is the coastal floating. So as the ice melt, it melts in the sea, and that increase the sea level. And as the sea level increase, the water will flood on the land, just as what happened in Libya a week ago. So this is a representation of Alexandria in 2100. If we keep increasing the Earth temperature, most of Alexandria will drown, and not just Alexandria. All the cities on the sea will be drowned. And the severe climatic change, like drought waves and drought will kill the plant and will face hunger. Heat waves, as we see in the summer, became very hot summer days. Tropical hurricanes, such as Katrina hurricane, or the hurricane that struck Libya 4 or a week ago. Forest fire, destructive flood, and we all saw what happened.
For 2.5 million years, the Earth's climate has fluctuated, cycling from ice ages to warmer periods. But in the last century, the planet's temperature has risen unusually fast, about 1.2 to 1.4 degrees Fahrenheit. Scientists believe it's human activity that's driving the temperatures up, a process known as global warming. Ever since the Industrial Revolution began, factories, power plants, and eventually cars have burned fossil fuels such as oil and coal, releasing huge amounts of carbon dioxide and other gases into the atmosphere. These greenhouse gases trap heat near the Earth through a naturally occurring process called the greenhouse effect. The greenhouse effect begins with the sun and the energy it radiates to the Earth. The Earth and the atmosphere absorb some of this energy, while the rest is radiated back into space. Naturally occurring gases in the atmosphere trap some of this energy and reflect it back, warming the Earth. Scientists now believe that the greenhouse effect is being intensified by the extra greenhouse gases that humans have released. Evidence for global warming includes a recent string of very warm years. Scientists report that 1998 was the warmest year in measured history, with 2005 coming in second. Meanwhile, readings taken from ice cores show that the greenhouse gases carbon dioxide and methane have hit their highest levels in the past 420,000 years. Arctic sea ice is also shrinking. According to NASA studies, the extent of Arctic sea ice has declined about 10% in the last 30 years. As long as industrialized nations consume energy and developing countries increase their fossil fuel consumption, the concentration of greenhouse gases in the atmosphere will continue to rise. Researchers predict that temperatures will increase about 2 to 10 degrees Fahrenheit by the end of the century. What's less certain is what rising temperatures mean for the planet. Some climate models predict subtle changes. Others forecast rising sea levels which could flood coastal areas around the world. Weather patterns could change, making hurricanes more frequent. Severe droughts could become more common in warm areas, and species unable to adapt to the changing conditions would face extinction. Although much remains to be learned about global warming, many organizations advocate cutting greenhouse gas emissions to reduce the impact of global warming. Consumers can help by saving energy around the house, switching to compact fluorescent light bulbs, and driving fewer miles in the car each week. These simple changes may help keep the Earth cooler in the future.
So the global warming and climate change is an urgent issue that faces the humanity and the whole Earth. Because as we increase the amount of carbon dioxide and methane in the atmosphere, we increase the Earth temperature, and that affect the climate, affect the weather pattern, with a frequent and more intense weather phenomena such as rain, heat waves, and floods, hurricanes, and that endangers all.